Hi everyone, welcome to today's webinar on how device intelligence can help CTV platforms gain competitive advantage. We really appreciate you joining us today, and we have a great lineup for you, including Director of Product Strategy at DeviceAtlas, John Leonard, who's going to be talking to us about how device intelligence can help CTV platforms in terms of enhancing user experiencing, facilitating targeting, and generally unlocking new revenue opportunities. Then we're going to hand over to Chris Gordon, who's Senior Director of Business Development at Xumo, who'll be talking to us about how device intelligence can assist publishers in driving higher CPMs for their clients. And then last but certainly not least, we have Director of Technical Operations at Magnite, Brian Garey, on the importance of device classification in a multi-platform ecosystem. So without further ado, I'm going to go hand over to John.
Hello everybody, and many thanks for joining. I'm going to start by talking a little bit about DeviceAtlas background. So the history really is DeviceAtlas was launched as a product in 2008 by the company .mobi at the time. DeviceAtlas is now actually the company. We have a deep background in mobile and web technologies, but now the company is solely focused on device intelligence, and we have a broad device intelligence portfolio. We're headquartered in Ireland, Dublin, Ireland, and we now have customers in over 70 countries. And some of our larger customers are very heavy users of DeviceAtlas. So to give you a number, Adobe, for example, do 150 trillion lookups in DeviceAtlas per year. So that's just to give you an idea of the extent which DeviceAtlas can be used. In the analytics vertical, we supply web analytics platforms, consumer analytics players, video analytics, network analytics. So very diverse use cases just in that vertical alone. But across many verticals, DeviceAtlas plays a role as a source of device intelligence to enable a wide range of use cases, which I'm going to talk about a little. So if we go into what device intelligence is about, really, device intelligence is about understanding the nature and capabilities of the end user device through which they're consuming content and services. And device intelligence is gained by a real-time lookup of the signals from the device, such as the HTTP headers, model strings, or TAC or IMEI, and converting that in real time into rich metadata. And this, we typically break this down into three layers. The first layer is device identification, which is really the foundation. The first step is to understand what is the brand, what is the model, because everything else follows on from that. And even within that layer, it's pretty important to be able to understand not just the model. So for example, if you know the model is SMG950F, that doesn't yield much insight. But when you know that's part of the Samsung Galaxy S20 family, for example, at that point, that's more meaningful. So knowing the family in which a device model belongs is a powerful value add at the identification level. At the level above, the next level up is what we term categorization, which is really about understanding the characteristics of a device. What are its capabilities? What are its properties? What are its limitations, which is also important. And this covers a really wide scope, down to hardware capabilities such as the screen size, the resolution, the connectivity capabilities. So for a cellular device, is it a 2G device or a 5G device? In the CTV space, it's vital to know what codecs it supports, natively or otherwise. Finally, core hardware characteristics like number of CPU cores, GPU, RAM, storage, all of that gives a good view into the performance capabilities of the device. And the final step in the device intelligence ladder is verification. And this is really about assuring that the device is what it claims to be. So there's many scenarios where a device may seek to access content or services, but it may masquerade its identity. It may pretend to be something it's not. And this is quite a common symptom of fraud attempts. So the overall device intelligence stack encompasses identification, characterization, and then verification. And the beauty of this, actually, all of this is non-PII. There's no dependency on user information. All of this is really about the device model and its characteristics. But why is device intelligence important? And to understand this, it's worth looking at the content journey. So obviously, content authoring is a huge endeavor. A long process, enormous investment and time goes into this segment. We don't play a role there, but the next step in the journey typically is the publisher, the organization that looks after ensuring the licensing and subscriptions are all in place and correctly managed. The publisher, in turn, depends on a content delivery network of some sort, whether it's a specialist video distribution platform or a specialist CDN. There always needs to be some means by which the content publisher can make their content available to the subscriber. But the next step in the chain, after the content delivery chain, is the actual connected device. And it has the role of retrieving the content, decoding it, and presenting it. So that's a really important step in the journey, because its capabilities really govern and bound the end user experience. And within that, to understand its abilities, the connectivity is important, the hardware performance is important, the codecs are important, and the screen capabilities are important, because taken all together, this is what defines the end user experience. So in a way, this is a digital content landscape, but the consumer is analog. It's the connected device that does the conversion of the content from the digital experience into the analog experience that can be consumed by the consumer. And another way to think about it is that the connected device is the last mile. It's the last step in the journey, but it's also the moment of truth. It's the point at which the consumer makes contact with your content. So from that point of view, understanding the device is vital if you want to understand and manage the end user experience. So how is the intelligence used? And typically it's a journey. Businesses often start with analytics to understand how diverse devices actually interact with and perform. So analytics is about understanding the range and variation of capabilities in data. That in turn informs user experience and optimization decisions, and subsequently also monetization. Device intelligence is a vital tool in the monetization chain. And finally, security and fraud management, security assurance, all of that depends heavily on good device intelligence. But what I want to do now is go into this in more detail, the use cases in specific segments in the chain. So we start with the online video platform, and there are four areas of use cases I want to touch on. So the first is subscription protection, and the simple premise here is to know your customer, know their device. And a standard use case for device intelligence is to create and maintain a device graph. Since the publisher typically has deterministic knowledge of their subscriber, they can also create a record of the devices which the subscriber uses to access content. So when John Leonard logs into a publisher platform with a particular device, there's a record can be created that this is one of the devices I use, and a set of devices, if the login is made across different devices, they can all add into the device graph with their characteristics as well. And so over time, a picture is built up of a device graph, but also a household graph. What devices are typically in a household? And there's a wide range of use cases for this data. So firstly, subscription access protection. If it may be desired to limit the range of devices which a subscription can be accessed as a way of controlling or limiting sharing. And so a simple example is to simply prompt for a login or an additional authentication step if an additional device outside the whitelist attempts to log in. And another example would be if the number of different devices accessing a particular subscription is deemed excessive, it might be opted to maybe turn on advertising as a way of monetizing rather than necessarily cutting off potential customers. So lots of ways to understand it, lots of ways to set policy from it, but understanding the subscriber device is really a core capability. Targeting is another way of using the device graph. The information about devices allows inferral of a considerable amount of information about the user. So if it's a premium device, or if there's a range of premium devices associated with their account, you can make assumptions about their disposable income. If they've got a 1-year-old TV as against a 6-year-old TV, you can make assumptions about whether they're an early adopter profile or not. And finally, brand sensitivity. If they're using a mainstream brand for the territory, then conclusions can be drawn from that, as against if they're using an emerging market or a lesser known brand that may have excellent price performance ratio, but isn't a known brand. So again, targeting, things can be inferred from the device graph from a targeting point of view. Finally, support communications become straightforward, and you can avoid spamming your base. If you know there's an issue on a particular model, or even down to a particular OS, you can do a targeted communication to just the subscribers that use that device, that brand, that model. And this is a far more efficient way of communicating with the base. And this could also be used to communicate update recommendations or solution resolutions. All kinds of communications just become highly targeted. So this is really use cases for a device graph. Then at the in the delivery chain, the encoding of the content can be highly informed by the device capabilities. So the design of the adaptation ladder can be based on what diversity of device capabilities are exhibited among subscribers. And it's more efficient, obviously, if fewer encoded versions can be stored. You have the resolution and the frame rate, the codecs, and all of that amounts to different bit rates in the stream. And the more devices you can cover with the minimum number of encoded versions, the better. But this is all about optimization. And this comes to the real-time step. If a subscriber logs in with a device you haven't seen before, the device intelligence capability tells you its capabilities. So you can select the optimum encoded format for those device capabilities. So factoring in things like the number of CPU cores, the clock speed, the RAM, the screen size, the screen resolution, all of those things help you determine what is the optimum bit rate to serve to this subscriber. Now, obviously connectivity is a factor as well. That needs to be considered in the determination of the optimum bit rate. But the combination of the device capabilities and the current connectivity performance is a key information in delivering the optimum bit rate. Finally, analysis of results. After the fact, analysis of QoE, session duration, etc., various business metrics, these can be correlated against different device characteristics to help fine-tune the adaptation ladder. So getting into device analytics in a little more detail, the simplest is enriched reporting. I mentioned that understanding the consumer name of the device is very valuable in analytics because reports are so much easier to consume when they use device families rather than device models. It's also far more efficient because if you want to compare the Samsung Galaxy S20 family against the Samsung Galaxy S23 family, you don't have to go down to individual model levels. You can roll up the data into families. So consumption of reporting becomes easier. And then pattern and trend identification. The real value in analytics comes when looking at key business metrics and correlating them with device characteristics. So you can identify what device characteristics influence business outcomes either positively or negatively. And that allows definition, or it allows fine-tuning again of the adaptation ladder to optimize the outcome. So if, for example, you see patterns for 4-year-old devices that you don't see in 2-year-old devices, you can make adjustments so that for every 4-year-old device that makes connection, you can serve it appropriately and appropriately formatted content. Another use case for the analytics is to measure the performance of ad partners. So as a publisher, you know what you should get from your SSP partner because you know how many CTV impressions you're generating. If you have deeper insights into that, it allows you to, again, compare with their reports and more easily identify any discrepancies. So you can forecast better, you can analyze better, you can report and understand better what how your ad partners are performing. And finally, the broad aspect here is that deeper intelligence on devices both informs policy definition, but also allows enforcement of policy because the intelligence is available in real time at the moment of the connection by the subscriber. You can actually both define policy and implement it. Then finally, IP and revenue protection. This ties back a little bit to the subscription sharing. One of the things you might note, if a publisher does implement a subscription sharing limitation based on the device whitelist, what may happen is subscribers may choose to use a user agent switcher, which is a simple downloadable app or browser toolbar item, and simply tweak the user agent string to masquerade as another device which is already on the whitelist. So that will work fine in most scenarios, but not if you've implemented a verification layer as part of your overall device intelligence. It will allow you to see immediately that if the user agent string doesn't match the device characteristics, that gives you a signal that there's a mismatch, and you can decide how to handle that scenario. Do you reject it? Do you accept it or follow up? Or that's a business policy question, but the key thing is to understand, is there a mismatch between the presented user agent string, HTTP headers, and the actual device itself? Protection of the high value assets. So the high definition movie, for example, is a very valuable asset. What can happen is a server may masquerade as a consumer device to seek to access high value content streams, and identifying a server when a server is masquerading as a consumer device requires a verification step. Typically, the core count, the CPU core count, is one of the most straightforward tells of a server seeking to emulate a consumer device. But the verification step does help protect you against this kind of content theft or potentially piracy. Finally, traffic analysis to identify bots and crawlers seeking access to content and services. So there's a range of use cases for device intelligence really to help protect intellectual property and revenue streams. So that's everything from the OVP point of view. We can touch on use cases in the SSP. Chris will go into a little more detail in some of this. Broadly, though, the SSP or exchange, it's about maximizing the return for the publisher, but also about ensuring transparency and confidence. So firstly, bot filtering. The exchange needs to be able to identify bots and filter it out to ensure marketplace quality. And that's really about brand reputation for the exchange themselves. The big step, the most important step, is populating the device object in the OpenRTB bid request. So the device object contains a limited set of fields about the device, but what's really important in the first place is understanding, am I dealing with a CTV impression, or is it a tablet, is it a desktop PC, is it a mobile phone? Understanding the nature of the device is pivotal to populate the device object correctly, because that materially affects the value of the impression. So populating the device object is the key step by the exchange, and that step allows or potentially increases both the number of bids and the value of the bids, because the DSPs downstream have a better understanding or can better value those impressions. And then reporting to publisher partners, a use case here for device intelligence is ensuring if you have consistent device information with the analytics platform your publisher partner is using, this helps to reduce reduce discrepancies, and thereby increase confidence. So obviously there's many causes of discrepancies in the advertising chain, but if you can reduce the ones related to devices, then that all helps overall performance. Finally, I'll touch on some use cases in the DSP, and Brian from Magnite will talk about this a little further. This is really about optimizing the outcomes again. Firstly, campaign management interface. Some DSPs provide very fine-grained targeting capabilities, and device intelligence is a valuable tool to populate campaign management interfaces with device information. So, for example, you could allow advertisers to target, say, TVs released in 2023 or later, or maybe target TVs from 2016 or older with upsell messaging, or maybe target premium smartphones or tablets as against entry-level smartphones or tablets. So there's many aspects of device intelligence which provide value for targeting, because I think it's obvious that premium advertising brands will typically want to target higher disposable income users, and the device is an indicator towards that. Then in the runtime, analyzing the bid request itself, the DSP checks the device object in the bid request. They could use device intelligence to populate any missing data, or they could verify or validate the data that's there. But an important additional aspect is enriching it further with supplementary information about the device from their own device intelligence capabilities, such as, for example, the user agent string or the SUA object associated with the bid request. They can use that to do a further lookup for deeper intelligence or different device information, which could be used for finer-grained targeting. So, for example, as DeviceAtlas, we work with ITC to provide pricing information, which allows targeting based on device price, for example. Then in the ad serving stage, the content, the format of the creative, creative is typically prepared in multiple formats to allow for different devices. So the so rather than expecting the device to render it, by serving the optimum format straight away, you get a cleaner and smoother experience. So the selection of the format of ad creative leverages device intelligence as well. And finally, DSPs may have their own DMP, and then they can use device intelligence to populate that and maintain their own device graphs and household graphs to support their targeting and analytics offerings. So that's really a wide range of use cases there for different players in the chain. So in summary, device intelligence really provides depth of information, which really opens up a lot of possibilities. But what we see in the market is that data-driven companies, they're typically hungry to deepen their understanding of what's going on. They want to understand everything that could have an influence on business outcomes. And using the rich information available through device intelligence, it allows them to not just understand the landscape, but also harness it to their advantage. And the challenge really is massive device diversity. New devices are coming out so fast that it's a real challenge to stay on top of. So using a device intelligence source allows you to stay on top of it and maximize your results. But a key aspect is that initially it's about analytics, understand what does your consumer base look like, but then you can take a step beyond that. If you if you enable content optimization so that lower end devices, for example, can present your content effectively, you're not just widening your base of users, you're extending the reach of content into new markets. So sensitivity to the device and allowing support for poorer connections really extends reach, and that's a massive business outcome. Secondly, you've got an element of fraud control. You can deepen and enhance your fraud control or fraud monitoring. But finally, and perhaps most importantly, what we see among our customers is they see device intelligence as enabling an optimum experience of their brand first time for a new user or a new subscriber. So irrespective of how the subscriber chooses to access content and services, you can ensure they get a good experience. And ultimately, that's a good brand experience, and that drives loyalty and growth. So I think that's everything I wanted to cover here. I would like to thank everybody for joining, but also if you have any questions, please submit them through the chat. And I'd like to hand over to Chris Gordon of Xumo.
Many thanks, John. That's wonderful. May I give you an introduction to the device graph in FAST from Xumo? Xumo is both a platform and a publisher. We offer a platform which involves televisions being sold in mainstream retailers across the US, and we have a series of set-top boxes which are available both through retail and through cable companies, enabling cable companies to provide a cable-friendly platform which enables audiences to subscribe to video services. In addition, we are a B2C FAST service where we provide free ad-supported television as an application which can run on many different platforms. That's a full screen video application served and delivered, providing advertising full screen television. We also have a couple of different other arms to our business, which is the Xumo Enterprise, where we are able to take ad-supported content and power other people's platforms through their own brand. And we have an advertising arm to our business.
Hey, Chris, sorry to cut you off. I'm actually not seeing your presentation, by the way.
I'm so sorry. I'm so sorry. That is, let me. I definitely did share. Let us share again. Window. Brian, would you give me a confirmation?
Beautiful.
Thank you very much, sir. Some of the platforms and systems which we operate on are here in the Logo Cloud. Most of the mainstream television platforms out there across the world, most of you will recognize those brands. We also power platform or serve content onto other people's services, and some of you recognize the logos within the middle section there. And then we work with monetization partners like our good friends from Magnite and the Trade and various different companies within the ecosystem. So John's given us an overview of the device graph, and I want to explain why the device graph is important to publishers and platforms like Xumo. Let's take a nice simplified device graph presented in a generic analytics system. And that's giving a proportion of, at the top level, of these are smart TVs, these are mobiles, these are desktops, and there's a proportion of unknown where some of those devices are not classified. It's critical to publishers like myself that those devices are classified correctly. And that is important to protect the value of that ad inventory. We, as Xumo, are providing smart TV services, and those smart TV services command double-digit CPMs when that advertising is sold. When it's desktop or it's unclassified, unfortunately, those same impressions may only command single-digit CPM. So it's absolutely critical for us as a business to understand that to ensure that our devices are classified correctly. Other things is essential is quality reassurance to our buyers of our ad inventory, ensuring that their end of campaign reports are accurate, that the analytics is reporting nicely, and those kinds of things. John mentioned user experience, and when we are serving ads through our ad partners through to end user devices, it's essential to make sure that the correct ad creatives are served to the correct types of devices. And those of you might have seen the use case where an interactive ad is served to a non-interactive device. Someone is expected to click here and it's on a television, which may not necessarily be appropriate for that particular campaign. So it's pretty useful from a user experience point of view. And then finally, from a transparency point of view, as Xumo, we want to ensure that our inventory is some of the highest quality out there, from the top brands on top content brands on highest quality TV devices, full screen, etc. And we want to make sure that our devices are not misclassified by third parties. So that's why it's essential for the device graph to be accurate. My problem is that I know that 95% of my audience is full screen, smart TV, and set-top box, which should command the highest CPMs in the industry. But unfortunately, what I think is irrelevant. What is relevant is that all the other participants in the advertising ecosystem know that my devices should command those higher CPMs. And that's a broad ecosystem. It covers the ad servers, the ad platforms, verification systems, the buyers, and the agencies. So we do have a problem, which is that we need a common ecosystem, or across the ecosystem, we must be able to rely on an independent, trusted verification source for device classification. And that's where John has presented the solution from DeviceAtlas. So that, as a publisher, that's my problem and that is my challenge. We'll dig down into some data into a little bit more and look at the Xumo device graph. 95% of my usage is smart TV and connected devices. And that is usually inferred from the magic string, which is the user agent. Within that 95%, 40% of that, I can define the user agent because I am the app publisher and we've written the code, we've used the right SDKs, and we have able to present that it's coming from Xumo Play, that it's on Apple Fire TV, etc. Good example. It's a very clean ecosystem and we can present that nicely. When we integrate with some other platforms, which are more likely to be the smart TVs, the app ecosystem inherits the user agent from the platform. So that might be a 6-year-old smart TV with a particular SDK. And within that 60%, Pareto's law still applies. 80% of those are nicely formatted. But unfortunately, there's an element out there which are devices which are no longer receiving updates to firmware, where the user has chosen not to update the OS. So there is an element of ambiguity in right at the end. And that is where someone like DeviceAtlas helps make that graph or device graph become more accurate. So that's why we rely on third parties like DeviceAtlas to ensure that our inventory is represented accurately through everybody else's third-party systems, and they have absolute confidence that as Xumo, we're selling full screen, smart TV, cable TV inventory, and our buyers and platforms are reassured that that is accurate. Unfortunately, it kind of gets a little bit more complex than that, because you build yourself a nice little application like Xumo Play, and it might be on an HTML5 or a browser-based platform, and the user agent comes out from the browser. Then you kind of need to do a full screen ad, and you go and apply a video ad SDK into the stack. Then you might add a video player SDK into the stack, or you might rely on the underlying hardware player within that app. Unfortunately, within that chain, 4 different user agents could come out of that device, and that is a challenge challenge to us as a publisher about making sure that user agent, whether it's a request coming from the browser part of the app, whether it's coming from the video SDK or the ad SDK for the impressions and the pixels, whether it is the video playback side of things, I need to make sure that is consistent across the board. And as I plug in third-party tools and SDKs, it gets a little bit more complex. So as a publisher defined user agents, we've got to worry about pixels, players, SDKs. Good news is the IAB have some preliminary guidelines which were put together a couple of years ago. So those of you who are interested in looking at what the IAB considers best practice, there's some documentation out there, and DeviceAtlas were part of that standard. The challenge, of course, remains those platform-defined user agents which are out there, making sure they have a well-defined user agent. But if they don't, we're then dependent on organizations like DeviceAtlas to make sure they're classified correctly, because those devices may not ever get a firmware update. So let's look at a worked example. Let's look at a worked example of something like a Xumo Play user agent, which is being classified by DeviceAtlas. And the user agent is at the bottom of the page if anyone is interested in reading that string. But from my perspective, what is essential for me is knowing that it has been identified by DeviceAtlas as a set-top box. It's a set-top box, but it's not a TV. So we can see some of those signals in the hardware section there. We're also seeing that it is an app. So DeviceAtlas correctly interpreted that is an app. So it's an app on a set-top box. That's even better. We've identified that it's not a browser, which is even better, because I then have no risk of anyone classifying me as desktop. And it is a primary software type of being an app. So that's an example of a nicely structured user agent string which has been put into DeviceAtlas and has been accurately identified with the key things which I believe my buyers would be interested in to ensure I command the highest CPM for my inventory. So we've been doing this a while. Wanted to share some of the lessons that we've learned from the field for a publisher. If you've got the opportunity to define the user agent, follow the standards and guidelines. There are standards and guidelines and conventions out there, but use them and make sure you just don't go off-piste. If you're inheriting the user agent from the platform and it's not optimal, there's a temptation to spoof the user agent. Never do that. It will only ever lead to discrepancy and questions raised within the ecosystem from your partners. But the good news is user agents do support extensions, and you are able to append and augment additional information on the end of the user agent string. And that's a far better way of operating, is to use the extensions and provide additional information on the end of the string, rather than overwrite the string, spoof the user agent, or think that you are trying to improve the situation. Inevitably, it will get worse. If you're running an ad system, and you are passing or you are using ad tags within your system, many different ad servers have a macro or KVP where they say, oh, insert your user agent here. Our experience is don't do that. The user agent is usually passed within the HTTP headers. Let the headers do their thing. We actively discourage anyone from passing user agents within ad tags. It can only lead to discrepancy between what the headers say and what the ad tag says, and that is suboptimal. As we said before, watch out for those video players, SDKs, server-side ad insertion and application framework where they may modify the user agent. Your nice little HTML app might be sending the platform user agent, but a Vast SDK or video SDK might be sending through something entirely different and possibly useless. Watch out, any app which you produce, there may be possibilities of multiple user agents coming through, leading to discrepancy within the device graph. And work with your ecosystems, talk to your partners, ask what they are seeing from your traffic and see whether their inferred device graph matches your inferred device graph. And to achieve that, it is to audit your estate regularly. Look at your logs, look at your server logs, see what's coming through, quantify, focus on the largest user agents first, and then gradually groom and manage your estate to make sure that all your inventory and devices are being correctly classified by upstream systems. And something like DeviceAtlas helps you do that, and helps your partners who are using that data audit the estate. If you're launching a new device or platform, take care over that user agent because it is absolutely revenue affecting. If your traffic is getting misclassified as desktop when it isn't desktop, or it's getting misclassified as other, I've never yet found an ad buyer who has actively gone out to launch an ad campaign where they would like to target devices called other and unknown. So make sure that you are trying to reduce that section and talk to your ecosystem partners within the ecosystem to make sure that is accurate. Don't just leave it to your well-meaning developer to just make up a user agent. They won't understand the intricacies of the ad buying ecosystem. They've probably just renamed it as the module or the framework that they are using and expecting that. Unfortunately, that will lead to discrepancy. So it's pretty important to work with your partners to review that and make sure that you're accurate. And there's some super advice on the DeviceAtlas blog in there. They detail some of the best practices. So I would encourage those of you to have a read of that. And if you're a platform or a manufacturer, go talk to DeviceAtlas. I encourage the platforms to make sure things are right from the very ground level, which then means when app publishers build upon those platforms, they can safely extend the user agent, but they are at least dealing something which is built on stone rather than sand. So for the platforms and the OEMs, I would encourage them to talk to organizations like DeviceAtlas and get that user agent accurate from day one. For those of you who produce frameworks, video players, and SDKs, please don't arbitrarily overwrite those user agents when someone uses your SDK, because you will end up impacting your publisher's data. You'll end up impacting that device graph. It can be a bit of a challenge. If you're in ad tech, exchanges, SSPs, DSPs, engage with trusted independent services like DeviceAtlas, who are that common source, and make sure that your analytics platforms are also matching others within the ecosystem. And then if you're a verification service, talk to your publishers. Don't just say, well, I think that data is wrong. I think that data is wrong. Never attribute to malice what could be oversight. Talk to your publishers, talk to your applicant partners, and help them understand if there are oversights within the user agent or things being misclassified. Help people fix it rather than just market it as invalid traffic. So hope we've managed to cover some of the areas today, and I'd like to hand over to Brian at Magnite, who can share some of his experiences within the monetization side of the device graph.
Yeah, thanks so much, Chris. And thanks so much for those summary slides. Some really solid, tangible things that I know you guys learned the hard way. So thanks for sharing those. Thanks everybody for joining today, and major thanks to John, Kate, and the DeviceAtlas team for having me. My name is Brian Garey. I'm a director on Magnite's technical operations team. I've worked in ad tech for over 10 years, and I've had the pleasure of working with John and the DeviceAtlas team for more than half that time. I'm based in the States in Boise, Idaho, and when I'm not solving ad tech problems, I'm usually outside in the mountains. So in my session, I'll be covering who is Magnite, who do I work for, how does Magnite use device detection, and then I'm going to talk specifically about user agents and device targeting. So who is Magnite? Magnite is a publicly traded company in the United States, and it's a company that's been built through mergers and acquisitions over the past 5+ years. And it's made up of the best-in-class supply-side advertising platforms in the industry. So Rubicon was the leader in display and online video advertising. Spotix and Telario were leading OTT and online video SSPs. And Springserve was the leading OTT ad server in the space. And together, they've created the largest independent supply-side company working across all verticals that you see listed here. Although you might not have recognized those brands, hopefully you recognize some of the brands on this slide. These are media companies that use Magnite to power their advertising business. And one that's not listed here that we just recently did press around was Netflix as well, which was a major milestone for the company. So now that you know a little bit about me and who I work for, let's talk about why we're here today. I think it's really important to start with the user agent. The user agent, this long alphanumeric string that you see on the screen, is the identifier at the heart of our discussion. So every device, your cell phone, smart TV, PC, tablet, etc., has a user agent. And as John and Chris talked, these user agent values are mostly standardized, and they are used to relay information about the device. So by working with a device detection vendor like DeviceAtlas, this user agent string that you see on the left can be translated into human readable attributes that you see on the right. So in this example, again, that long string was actually a user agent for a Comcast set-top box device, which we can see on the right by looking at things like the brand name is Comcast, and the device type is set-top box. So why is this process important for Magnite? So when a user is streaming a movie like Thor on a good app like Xumo, and there's an ad break, that call goes from the client, from the device, to the Springserve ad server, then to the Magnite Streaming SSP, and then to our buy set of tools called ClearLine. That's just 3 connections just on our own platforms, and there are certainly scenarios where there are a lot more platforms and a lot more connections in this workflow. Each one of these arrows represents a server call, and these server calls contain a lot of information about the end user watching the content itself, where that user is based or the geography, and you guessed it, they also contain the user agent and information about the device. And all that information needs to be conveyed in each one of these calls. So each of the Magnite platforms uses a device detection vendor to translate these user agent values and do what they need to with that, which we'll talk more about. And although this might seem somewhat trivial on the surface, it's important to keep in mind that these Magnite platforms see billions of requests per day, and we see thousands of different devices per day. And programmatic buying is really based on the quality of the signals that are passed. And so it's really important that this process works and that it's accurate. So again, we started with this string, but somebody in the Magnite platform like ClearLine sees all of these options when they're setting up a campaign specifically just for device targeting. So, as you can see here, they can clearly choose on the left the brand, they can choose the model, the operating system, or browsers that they want this advertising campaign to run on. So they get to choose, it can be broad at the device level, or it can be very specific which devices they want this to run on. And if there are any traders or ad ops folks on the call, you know how often device targeting is applied to programmatic campaigns. It's extremely common and it needs to work as expected. So this is really important that we get it right. Chris talked about this a lot, but the price of different devices varies pretty widely. So a campaign that's targeting desktop versus a campaign that's targeting premium OTT are going to garner different CPMs and different price points. And so it's important that the trader is able to choose these and have these targeting settings work effectively. So I focused in on just one use case. I think John talked about a lot of use cases for the DeviceAtlas technology, but I just wanted to focus on one specific and probably the most prominent use case that we use at Magnite. And so the key takeaways for my portion is that device detection allows Magnite to understand key information about each device, and it allows our customers to action off human readable device information to ensure that their advertising campaigns run on their desired devices. And that's all I got. I think I'll kick it back to Kate at this time.
Thanks, Brian. That was great. And thanks also to John and Chris, of course. So we have a little bit of time left. So if anyone has any questions, you can pop them into the question box just on the top right of your screen. But yeah, thanks so much. It was great. Those were 3 great presentations. I actually have a question to get us started. So if one of you guys wouldn't mind, wondering when there is a set-top box and also a TV, what's identified there?
I can probably take that, Kate. The connection to the streaming service will come from the set-top box in that particular case. So if it's a set-top box connected via HDMI, or it is a stick which is plugged directly into the back of the HDMI ports on the TV, it will come from the box itself. If it is a native service running on a TV as the native app, it would come from the TV itself.
Oh, okay, cool. That's good information to have. It's kind of a confusing one, so it's great to have that clarity. Obviously very important. So we just have a question in here. Is it possible to know the end user connection in real time?
I can answer that one, I think. What's important in web or internet connectivity is that as part of the handshaking process in the IP protocol, the HTTP headers form the handshaking process between the browser and the server to which it's connecting. So the browser passes the HTTP headers. That's pretty much the very first thing that happens. So at the server side, it can examine those headers, run a device intelligence capability to parse out those headers and identify the device, and that's microseconds. So high volume platforms might have enormous levels of traffic, but the process by which the HTTP headers are converted into rich information is actually a very, very compact, low footprint process, very high speed. So it's virtually real time.
Oh, okay, that's really cool. So just another question in here from Mike. Is the technology GDPR safe?
I can answer that one. When we talk about device intelligence, we aren't talking about users. So, for example, to speak from DeviceAtlas perspective, DeviceAtlas might identify this is a Samsung Galaxy S20. It doesn't say this is John's Samsung Galaxy S20. The HTTP headers, by definition, do not contain user identifying information. So device intelligence itself provides information about the device model and its capabilities. Now, many customers will add their own layer of user intelligence on top of that because they can create the association between the device and the user because they have deterministic knowledge of the user. So they can create the associations. But a device intelligence service typically will not itself provide user information.
Okay, good to know. Thanks, John. And then I have another one here. What happens if the UA string doesn't match the device? This might be a good one for you, Brian.
Yeah, for sure. I can take that. Yeah, we do see that at Magnite at times. If the UA string doesn't match the device, ultimately, like that's usually a result of a lot of what Chris was talking about, maybe the app developer making changes to the user agent string. But what happens is we at Magnite see the user agent string at both the ad request and when the actual ad is served, we see what we have like event beacons that fire. When those event beacons fire, we actually get the user agent from the header from the client as well. So we'll be able to basically discern, hey, did the user agent match the device? Is it what was actually passed in the request and at impression? If those don't match, that is something that gets flagged by brand safety vendors that we work with. That is problematic, and it's something that we work with partners on. It's not something that doesn't happen ever, and it's usually something that can be fixed. If it is something that happens consistently, that's usually flagged as again like brand safe, and usually will work to move away from that supply.
Okay, so lots of checks in place. Great. Cool. And then we have one more, unless anyone else has a question. So what happens, when there is, what's the standard format for a UA string?
Shall I take that one? Or any other
Yeah.
volunteers? I think it's worth going back to the HTTP protocol, which defines the goals and the content of the UA string. But that goes back to the 90s. And it was defined at the time with very simple goals. It was to enable the server to understand capabilities and limitations of the user agent. So the user agent string is a communication of what the user agent can do. However, over time, they've become, it's morphed widely. But the IAB, we did work with the IAB a few years back to make some recommendations on a consistent approach because there is enormous diversity out there. And as Chris alluded to earlier, what often happens, particularly with TVs, TV manufacturers, relatively speaking, they're new entrants into the whole world of HTTP. So the core development teams don't necessarily understand the implications of the HTTP protocol and the importance of the UA string, as Chris mentioned. So often that's where you get a user agent string that's not meaningful, and therefore you lose the ability to power analytics effectively, and you lose the ability to monetize content effectively. So organizations like the IAB do provide recommendations on this. But at DeviceAtlas, we work to make sure we identify everything out there. And that's obviously an ongoing challenge, but that's our core business.
Okay, makes sense. Thanks, John. So we haven't got any further questions. I think there's been so much information, everyone's satisfied. So we're coming up to the time now, so I just want to take a second to thank our speakers, John, Chris, and Brian. Great presentations from all of you, and lots of food for thought for myself, and I'm sure all our attendees. And also like to thank our attendees for joining us. It was great to have you. Thanks, everyone.
Thanks, y'all.
Thank you.